Okay, so we've got a cardioid here, so let's get a sketch going. So I need to just plug in a few points to find out what it looks like. So if I plug in 0 and pi over 2, pi, 3 pi over 2 and 2 pi, for sure I'll get a sense of the shape of this cardioid. So angle 0 gives me 0, pi over 2 is 2, this gives me 4, 2, and 0 again. Okay. So angle 0 is r equals 0. Angle pi over 2 is 2. Angle pi is back here at 4. Angle 3 pi over 2 is at 2. And angle 2 pi is at 0. Because I know it's a cardioid, I know it looks like this. Okay, so the sectors. The sectors come out from the origin, like pieces of pie. This is a sector. So we're finding area by sectors. 1/2 r squared theta. 1/2 r squared theta is the area of this here. You can see we cannot use rectangles, right? We can't use rectangles, so we're going to be finding sectors. We'll be adding them up and letting the theta, the angle, get super small so that we're finding tiny little sectors, right? A very small width or very small angle, just like when we were doing rectangles, we let the delta x get super small and we found the exact area. So this is sectors that are getting super small. So this is the formula for area. So here's my sectors. So if I'm going to find the area bounded by this whole graph, it's going to be 1/2 r squared d theta from 0 to 2 pi. So to find this area, or to do this integral, I'm going to need to multiply this out. So that would give me 4 minus 4 cosine of theta plus 4 cosine squared of theta. Oh goodness, I can see I have to use half angle formula on this one. So let's do the other two. So to take the antiderivative of 4 is 4, oops, I forgot the 1/2 here. Let me do that. So 1/2, so 4 theta, antiderivative of negative cosine will be negative sine. Carry the 4. So I can plug in 0 and 2 pi there. So I have this plus 1/2, let's not forget that. And then a 4 that's carrying along. I'm just going slow. Now to take the integral of cosine squared, I want to use the half angle formula, which is 1/2 1 plus cosine of 2 theta d theta. So let me go, I'm just going to use this space down here. So I have 1/4. I'm going to put the 2 pi in, so I get 8 pi. And that gives, sine of 2 pi gives me 0. So plus, so all of these cancel out. So now take the antiderivative. I get theta plus 1/2 sine of 2 theta between 0 and 2 pi. So carrying this along, I get 4 pi. Plug this in, I get 2 pi. Sine of 4 pi is 0. So all told, I get 6 pi. So that's the area that's contained by this graph. Let me erase this so I have room to do the next one. All right, so now I'm looking at the area bounded by r equal 2 cosine. So you're remembering, I mentioned many times, this is the one that just takes 0 to pi to go all the way around. So let's get those sectors. Those sectors always come out from the origin. So they look like this. So, all right. So let's be smart about this. So area is 1/2 r squared d theta. So I'm going to put the 2 cosine theta in here. So let's be thinking about these angles. So this is the angle 0. This would be the angle pi over 2. And this would be angle pi. So it just is 0 to pi to go around. So then this 2 gets squared. That's 4 divided by 2. There's a 2. Cosine squared theta d theta. Again, half angle formula, right? 1 plus cosine of 2 theta. 0 to pi. So these 2's cancel. So taking the antiderivative of 1 is theta. plus 1/2 sine of 2 theta between 0 and pi. So plug in pi, and that's 0, plug in 0. So there it is. The area bounded is pi. So just like when we did areas before, I'm going to have you set up the integral many times. But I just wanted to go through and show you the half angle formula that's going to come up almost every single time because you're going to be squaring the function.